So suppose a question says determine f double prime of x when f of x, oops, that doesn't look so good, f of x equals say sine of x squared. So suppose you're asked to find the second derivative, then given you have technology and so forth, you can use it to check, but it would be expected here that you justify it mathematically. You show the argument for why you have the right answer. So in this case, we would probably expect to see for an answer something like, well, f prime of x is equal to, and if you wrote, simply wrote cosine of x squared, and then it would probably be best if you wrote something like this, where you're showing you're taking the derivative using the chain rule, and then you could say this is equal to, and cosine of x squared times 2x, and then probably you should rewrite it as 2 cosine of 2x cosine of x squared, like that. And so you show that. Now, actually, if you didn't write that, but you wrote, this and this, yeah, I think that's probably fine. But now it wanted the second derivative, and so then, okay, f double prime of x, and again, I expect to see that you're using the product rule. Now, so you might write it out as, I don't know, you could leave the 2 out of it and just put it out front, or you could say something like the derivative of 2x with respect to x times cosine of x squared plus 2x times the derivative of cosine of x squared with respect to x. Now, it would be okay if you shortcut this a little bit and had wrote maybe 2 cosine x squared and then plus 2x times, and again here you could write this chain rule out with the dx squared dx, or again, since you just did a chain rule very similar to it, if you wrote in this case minus 2x, whoops, not cosine, sine of x squared, like that, that would be great, because, so again, if you didn't write that, in this step here, I can still see you are using the product rule. And so then, again, you ought to simplify this and a little bit. I mean, you don't have to do a great deal. Well, I put a plus, and you could put a plus minus, and then a negative 4, but probably it'd just be better to go with minus 4x squared sine of x squared. Now, so once you have that, you have technology available, so you are more than welcome to kind of check these things. And now I'm going to check both of them using Sage Cell, both derivatives, but only the first derivative with Desmos. That's all I typed in, but and I typed them in already just so it'd be a little quicker in the video. But so, there I do that work, and I show, my train of thought. I show how I got to this second derivative. And so if we go to well, let's go to, yeah, Desmos is up there. So if we go to Desmos, what's happening here? Desmos says I'm connected. Oh, it was just slow. Okay. It says I was connected to the internet. Okay. So here I typed in my original function, sine of x squared, and then, you know, I can get Desmos. Here's a way to check a derivative or a second derivative or whatever. You know, I can plot then the first derivative, and then here's my answer for the first derivative, 2x cosine of x squared. And so I plot that. Whoops, didn't plot it. There we go. And it's right on top of the green one. And so I could also do that with the second derivative. I could put in here another cell that said f double prime of x, and I could type in my formula for the second derivative and look to see that the functions sit one on top of the other. And they're, okay, I'm very happy that I got the right answer, okay, at least for the first derivative here. And so you could use Desmos to check that way. I have no issue with that. But again, if you just go to Desmos, well, for one, you're not going to get a formula out of Desmos. So, you know, you can use it to check your answer, and that's fine. Now, Sage Cell, on the other hand, I can go to a Sage Cell and I can type this stuff in, you know, my var x, type in f equals sine of x squared, and then do my first derivative, show it, do my second derivative and show it, and there are my answers. 2x cosine x squared, you know, and there's my 2 cosine x squared and my minus 4x squared sine x squared. There you go. I mean, there are the answers. Well, that's why I want you to show that you know the rules you're using and so forth. Now, when all is said and done, going back to something like this, you know, here, right, I said, well, I need cosine of x squared, because that's the derivative of the sine. Now, if you went to something, you know, if you went to Sage Cell and you typed in f equals sine x, you know, so if you did f equals sine of x, and then you did f dot diff with respect to x to get the cosine of x for that derivative, well, I would have no idea. And of course, you can look it up in your book and so forth. So I'm not worried about that. I am worried about you recognizing that there is a chain rule here and you showing me that you realize the chain rule and how to use it. Okay? And so, you know, using something like Sage Cell to get the derivative of the sine of x itself as cosine of x, great. You know, the derivative of x squared as 2x, great. I don't have an issue with that. It's that if I don't see you showing me that you know there's a a chain rule here, and if I don't see you in something like this showing me that you know it's a product rule, then you don't get credit. Yeah, I mean, you know, usually I give 4 points per right answer, and you know, that's just a thing I do no matter what the problem is, and so, you know, if you just type in the answer because you went to something like Sage Cell, and you know, and then you just give me something like that, you might get a point, you know, because I think it's a fine skill to be able to use Sage Cell and Desmos and so forth, you know, so in that way I think that's great. But you know, in the end, what we're really trying to show you are these theorems, you know, as to how we can do much more complicated things by doing the simple things, one at a time with these nice theorems. And so that's what we want to see in the math. And but you are, again, more than welcome to check your answer using the technologies. Okay, so there is the second derivative of sine of x squared, given that we do have technology available.